And good morning. Hello.
Good morning, sir.
Are you able to see the slide?
Yes, sir.
Okay. So as I've already told earlier, so we'll discuss today about the integer programming. Integer programming is a special type of linear programming problem where the decision variables are integers. Okay, integers, non-negative integers. So in linear programming, so we have an objective function, set of constants, some decision variables. The decision variables takes all the real value. It can be integer, it can be non-integer. Of course, they are all non-negative. Okay, but we will discuss today about the linear programming problem where the decision variables are integers. So linear programming problem when the decision variables are integers are known as integer programming. Okay, so the general model what we are presenting for the linear programming, that is integer linear programming, or you can say ILP or IPP, integer programming problems. So generally it is a linear programming or integer linear programming. We have a model like this. We have an objective function. Objective function can be maximization type, can be minimization type. Either it is maximization or minimization. And we have constants. These constants are sometimes less than equal type, sometimes equal type, sometimes greater than equal type. And generally, as you know, the right hand side BI are non-negative generally. And here in this integer programming problem, our decision variables are either 0 or 1 or 2 or 3 or can be anything, any non-negative integer. If we find the decision variables are binary 0 or 1, it is known as binary programming problem. It is known as binary programming problem. Here our decision variables are either 0 or 1 or 2 or 3, etc. Any non-negative integers. So in this problem, we have parameters. Parameters like the cost coefficient Cj is a parameters. Then the technological coefficients Aij. Then the right hand side parameter Bi. These parameters are happen to be all integers. Cj, Aij, Bi are all integer. If they are non-integer, we can make them integers by multiplying a constant factor. Okay, for example, our Bi is equal to 1 by 4. We can multiply with 4 or 8 or 16, depends upon our need. If Cj, let us say Cj equal to 1/3, we can multiply with 3. Okay, so if you multiply with a factor, the objective function value is increased by that constant, but the solution is not changing. That is the reason we multiply. But here, please remember, these cost coefficient Cj, the technological coefficient Aij and Bi are supposed to be integers. Okay. So in this model, see any constant means restriction, can be either less than equal type, can be equal type, can be greater than equal type. For simplicity, some problems we are considering maximization type problem, these constants are all less than equal type. Minimization type problem, constants are all greater than equal type. So maximization type problem, constants are all equal type. Minimization type problem, constants are all equal type. We can have also linear programming problem, constants can be mixed type, either less than equal type or greater than equal type or equal type. Okay, that's all. Any confusion in this model? Anybody has confusion? These are whatever I am talking, these are the possible question for you, but you will not realize how we can find question. Because here, when I'm saying Cj, Aij, Bi are integers, so we have to make them integers. Okay. So any doubt here? Any confusion? Anybody?
Sir.
Yes.
Sir, is there any constraint on sign of Cj, Aij, and Bj? Like they can be positive, negative, both, right?
No, they are real numbers. They can be integers, they can be non-integers. But here, so in linear programming, we don't say anything. But here, but sometimes, for some simple reason, we have taken BIR non-negative because our basic feasible solution depends on BI. If BI is negative, the solution will be infeasible. So it will be 0 or positive. Okay, that is the reason. But the AIJ are free. It can be positive, it can be negative, it can be 0. CJ are free. It can be positive, it can be negative, it can be 0. Generally, the cost can be positive, 0 permitted. Why 0? So you are purchasing some items, no cost, free, possible. So, and negative cost, positive cost. Negative cost means, so you have to, so he has to pay some money, not that. Okay, something like that. But here, generally, we assume the costs are either 0 or positive. The positive is ideal. Okay, but there is no restriction on them. Okay, but here we have posed some restriction that CJ, AIJ, and BI are integers. The reason is obvious. Say if you say non-integer, then you multiply with some integer. So non-integer multiply some integers, there is no guarantee that it will be integer. Integer multiply with some integer, the product is integer. But non-integer multiply with some integers, so there is no guarantee. Okay, that is the reason we assume they are integers, right?
Yes, sir.
Okay. Now this is a problem, a linear programming problem. See, as you know, if it is a two-variable problem, you solve using graphical method. Simplex method. So simplex, lot of methods are there. Primal simplex, dual simplex. If I'm asking what is the difference between primal simplex and dual simplex, all you know, what is the difference between primal simplex and dual simplex? Anybody still has some confusion? Anybody? How was your test, the OR test? I took early, of course, before the the schedule, so I announced, so I also conduct accordingly. Okay, because if you are waiting, then everything will be okay. So this week there was test for you for other subjects other than the OR. OR I have taken 1 week advance. Okay, so that is all right. So no problem. So similarly, you will have the second test. Second test when I told around 15th of March, isn't it? So say 1 week I can delay also, no problem. Okay, so because that depends on the preparation, depends on your the coverage. So 1 week delay, or so tentatively around 15th of March. Okay, so and you are writing code. See, I'm telling you, if you are writing code, indirectly or directly, it will be beneficial to you. How it is beneficial? Tell me how it is beneficial. See, you have some enemy. Okay, my example is like this. So don't think it is a absurd example. It may be an absurd example for you. So you have some enemy. What you will do? You will take the help of police? Yes or no? Right? Yes or no? Tell me. You have some enemy who is threatening and who is threatening to kill you or to disturb you. So you have some enemy. So suddenly you will report to your parents or the police? Yes or no? In case, for example, all the American citizens, they have gone, handgun. Okay, right? If any enemy is creating problem, they apply their own knowledge. Okay, they don't inform police, they apply their own knowledge. Okay, it is possible? Yes or no? In India, it is different. So, okay, I'm telling you, you have developed a code. Code is for what? Code is solving linear programming problem. Any types of linear programming problem. This is extra benefit to you? Yes or no? Extra benefit to you to check your answer whether it is wrong or right. Yes or no? So the simple mind, you should utilize that. You do experiment early, and if any problem, it will solve it. So whether your code is able to solve all type of problem or not, I don't know. So you test it there. Okay. Okay. Nobody is stopping. Nobody is, because this test is like that. Okay. So if you have more more activity means you have already done some experiment. So your experiment, whether it's success or failure, you know it. Okay. So if you are checking, I do not. So nobody object that you check. You don't check. But please remember, we have reduced the time. The test is supposed to be 1 hour. So we are giving half an hour. You know why? Because you are solving the problem in the groups. No problem, you solve it. Okay. If group is weak, your answer is weak. If group is strong, the answer will be strong. That's all. Right? So my request is you try to write code as much as possible individually and don't in group, because the clever person, you know, he knows how to manipulate the answer, but the poor person cannot. Okay. But I've seen, so almost all the students are clever, intelligent, they can do it, but they generally they don't. They take the help of others. But don't do, you try yourself. Okay. And it is a very good subject. This subject is there in computer science, in machine learning, in management, in mathematics, in statistics, everywhere, in agriculture also, right? So what I'm saying, so try to utilize, and even this linear programming model, it is so beautiful, you cannot realize. After sometimes, maybe when you become a professor or some scientist, that time you realize, yes, it is so beautiful. Okay. Recently, few faculty in mathematics department, they are joined. Their area of research is algebra, that too linear algebra. I asked, there is a problem, can you solve for me? They vanished from the department. They vanished. This is the attitude of the new faculty. This is the attitude. But I'm telling you are more powerful. You can do everything. But this is the time to learn and this is the time to utilize. Okay. So even sometimes something I will learn from you. Okay. So, but I'm saying here, these are the inputs. See, now you may ask me, sir, what are the software to solve the problem? So what you will do? You will not learn the subject. You will try to locate where is the software, how to solve the problem. But at that mistake, I will not do it. But if I'm telling, I will tell you at the end. These are the softwares you can utilize. You search, see, searching, if searching is successful, your research is successful. Research meaning is you are searching repeatedly. Okay. So if you can search and find out, it's fine. But if you cannot find out, I will tell you. Okay. I will tell you at the end, not in the beginning. If I will tell in the beginning, certainly what you will do, you will not learn the subject, you will learn where is software, how to solve. What the managers they do, they learn these are the models, how to solve such models. That's all. See, in the MBA course, OR is a technique they use, and whatever you have learned, I am sure no MBA students will be able to solve such problem quickly. Even some professors they cannot solve, because they say that we have forgotten the table. This is no question of forgetting. You have to remember and you have to utilize. Right? There is a rule. I am telling again. Use linear programming methods to solve system of linear equations. And conversely, use the linear programming method to solve the system of a linear equation. So if you know how to solve such a linear equation, then you can solve linear programming problem. This and that. So both are useful, both are related. And the linear programming is nothing but solving system of linear equations. But this is not a square system. If it is square system, the answer is very simple. You can quickly find the answer. It is not a square system. That's all. Now tell me, what are the methods are applicable to solve this type of problem? Let us say they are not these the decision variables are non-integers. What are the methods? Okay, anybody can clearly tell? I used to ask, this is a question, what are the methods? Tell me, what are the methods? Anybody? Hello? Are you able to hear? You see, already there are half dozen methods: primal simplex, dual simplex, primal dual, combined simplex. Why combine? Sometimes, when they are all less than equal type constants, we are using primal. Greater than equal type, then it is dual. If some are equal type, some are less than equal type, sometimes, So some are less than equal type, some are greater than equal type. We use primal dual combine. Some are less than equal type, some are greater than equal type, some are equal type, maybe big M method. Okay. So all the things you have to realize and you have to solve. Okay, that's all. Now I'm coming to the problem. How many students are presently available? Who can say? I'm not looking. I can find out. How many are there? See, at the end, I will take the attendance. Tell me how many are there? Anybody?
76.
Yes? Tell me.
76.
See, the test I took, so the test result, see, according to my thing is all right, okay, because the question was a little, lengthier and it is difficult to complete in 30 minutes. But even that, I find some few students have done very good. Even they got 30 out of 30. So, see, 30 out of 30 is a rare thing, but still it is possible, okay. But don't worry for that. So all will get good grade because if you will try. But if you will not try, so then it is not my fault. You have to try and you have to achieve. Okay. And this is subject and it will be very useful everywhere to solve certain problems. Okay. Solve certain problems. See, this type of problem, whatever I have stated, we will solve using cutting plane method. One is known as cutting plane method. Another is called branch and bound method. Okay. This cutting plane method and branch and bound methods. So how it is useful and why it is useful? Cutting plane. See, when we are solving linear programming problem graphically, as you observe, we plot these constraints and we find a feasible region. The feasible region is nothing but the intersection of all this, region of all the constraints. Okay, feasible region. So, with respect to the feasible region, we have certain extreme points. With respect to the extreme points, we are finding solution. Solution is, let us say, a non-integer. So now, this feasible region, we have to cut it, make it smooth. Okay, cut it according to our requirement, so that the extreme point instead of non-integer, it will be integer. Cutting plane. So, see, for example, you have a region. Okay, the region is nothing but a polygon. Okay, this polygons, all the extreme points. So extreme points represent the basic feasible solution. Okay, the basic feasible solutions are non-integer, let us say. So I want to make it integers. So we have to cut according to the requirement. How to cut? Okay, that summary said that is the cutting plane method. Okay, so which is forcing the non-integer solution toward the integer solution. The second one is branch and bound. Okay, so based on the solution, we are branching and we put some bound to the decision variables. Bound. Okay, for example, the decision variables, let us say x1 is a decision variable. This present value, non-integer value is 3.5, 3.5. Okay, bound. Bound can be 3 or can be 4. Depends on the problem. Yes or no? Bound can be 3 or 4. Okay. So if it's something 3.5, it can be 3, it can be 4, something like that. But how to branch and how to put the bound? So in a systematic manner, we'll discuss. Right? These two methods are very useful and very informative, and we have to use to solve the integer programming problem. Right? Here, I will tell you there are certain applications. Okay, certain application for the integer programming problem. One is called transportation problem. It is there in the syllabus, so we'll discuss very soon. Transportation problem. This transportation problem is a special type of linear programming problem. Okay, where the decision variables are all integer. Okay, then another is called assignment problem. This is also a special type of linear programming problem where the decision variables are, instead of integer, they are binary, 0 and 1. Then we have jobs of scheduling problem. Here the decision variables are also binary. Then we have manpower planning, production planning, transshipment problem. These are the special type of problem where the decision variables are either integer or binary, either integer or binary. These are the applications. Okay. So these are the, of course, linear programming problem oriented. There can be also nonlinear programming problems. So we are not, there is no scope to solve nonlinear programming problem. So we are discussing only linear programming problem. Okay. So now we'll discuss what? Cutting plane method. Okay. These slides I was thinking to pass you today morning. Then I thought of letting you first cover. Then I will. Okay. Which is better? Should I stand in the beginning or in the end? Tell me. Which is better? Anybody? You want? What do you want? You are not telling anything. You are silent.
Beginning will be better.
Eh? After covering it is better or very beginning better? Tell me.
Beginning is better.
Eh?
Yes,
Beginning.
sir. Beginning
You
is
will not
better.
come to the class. You will not come to the class. And not only that, somebody will be teacher and he will present to others. You understood what I'm saying here?
We can refer the notes while you're
in a
teaching.
class, somebody X is presenter and other are listener. But some students are so smart, after getting the slide, he will present, I will be the listener. You know that? See, in the chess, game chess, you know, the the soldier can be king also. After some time, yes, possible. Something like that. Okay. So I don't know whether it's possible or impossible, but I think a soldier becoming king means, a soldier becoming minister means, so means all the power he is capturing. Okay. So see, you have power, but suddenly I will not surrender my power to you. Okay. If you can capture, fine, all right. So you present after learning, see, whatever the way I am presenting, if you present better manner, it's fine, no problem. But first I should present, after that you present. Okay, no problem. The cutting plane method. The cutting plane method is developed by Gomery. Okay, R.E. Gomery is known as also Gomery's cutting plane method. So in the year 1958. Okay, 1958. I was born in the year 1958. Okay, it is very easy for me to remember, right? At first, an integer programming problem, a linear programming problem, is solved as a regular linear programming problem. Okay, dropping the integral condition. If the optimal solution happen to be integer, then terminate the process. Simple reason. A linear programming problem is given to you. You are solving. If you find the solution is integer, what will do? Nothing to do. Okay. It is in integer, already integer. So if it is already integer, so nothing to do. No work is left out. Okay. So at first, an integer programming problem is solved as a regular LPP by dropping integral condition. We are not bothering about the integral condition. We are saying these decision variables are continuous. So if the optimal solution, extra, it is a vector, happens to be integer, then terminate the process. Nothing to do, right? Otherwise, the secondary constraints, it is not constraint, it is constraints, will be added that will force the solutions toward the integer solution. These constraints can be developed as follows. These constraints can be developed as follows. How you can develop such constraints, let us discuss. Now, see this problem I have given at the very beginning. This is my problem. This is a general problem. But when I am discussing, I am taking a special type of problem. Special type of linear programming problem. Okay. Why special type? Because if one case you can consider and you can realize and you can develop, other case certainly you can do it. Yes or no? See, in the very beginning, you know, the duality theory, we have taken four models, and using the duality theory, we have developed all the four models, the dual of all the four models. Of course, there was no question I could frame from the duality theory. The reason is because the duality was covered at the end. Okay, at the end of the means after question paper is set, the duality was covered. So the duality directly or indirectly will be there everywhere. Okay, duality theory. Yes or no? So anybody has not understood duality theory? Anybody? Not understood? There are some mistake. I have corrected the file. I think I have sent the last file to you, or if not, I will again send. No problem. Okay. So anybody has not understood the duality theory? Anybody? You are silent. What is the reason? Have you taken breakfast? Yes or no? Tell me. Mr. Anuranjan? Anuranjan is there? Hello? Anuranjan? Mr. Padhi? Padhi is there? Hello?
Yes, sir.
Okay. The duality theory, all the 4 models you have understood?
Yes, sir.
Okay. And is it available in some textbook in the same form? Have you located? Because the textbook I have assigned there is the by H.A. Taha, and for several years we are teaching that is the book. That is something like a handbook type, but many things are not there. Many things are suppressed. Okay. So it is there. The duality theory is there in any textbook you have located, or is available in some lecture note. What you are searching online is available. Anybody? Is it available? See, I will do one thing. So I may take a special test that is optional, and those are interested to appear. Okay. So I will take the test. Those are interested to appear. The test is on duality theory about the 4 models. So is it all right? Is it all right? Anybody is interested to appear? So as a special test, you decide and tell me. If you are, then I will certainly take a test, and the test is like that. So I will give some problem and solve, and you will answer. Okay. And the test will be online. Online means, so I will conduct, people are sitting, and I'll see their video and they are doing, and I will ask. Okay. And for example, I will give 50 problems. So 2, 3, first to this people and something like that I will assign who will solve which problem. Okay. So that you cannot copy. Okay. Is it all right? Okay. So if you like, you tell me. If you don't like, it's fine. Okay. So the duality theory also in the integer programming directly or indirectly is useful. Okay. It is used. Okay. Right. So we will take a linear programming problem. Instead of a general model, we will take a linear programming problem where the objective function is maximization type. Right. Objective function is maximization type. And what about the constants? The constants are all less than equal type. And what about the BI? BI is non-negative. If BI is negative, and if you want to make positive, you will multiply minus sign. So instead of less than equal type, it will be greater than equal type. Okay, let us assume. So objective function is maximization type. Constants are all less than equal type. Right hand side BI is non-negative, and decimal variables, let us say non-negative. This is all right. With respect to that problem, so if objective function is maximization type and the constants are less than equal type, right hand side BI is non-negative. Okay, decimal variables are non-negative. Which simplex method is useful? Which simplex method? Yes, who can say? Objective function is maximization type, constants are all less than equal type, right hand side BI is non-negative, and decimal variables are non-negative. Which simplex method is applicable? Who can say?
Primal simplex.
Primal simplex. Right answer is primal simplex. Because I was saying initially it's simplex. When the dual simplex is covered, now we have given renaming this simplex method. The first simplex method is known as primal simplex method. Primal simplex method. Now we will discuss the integer programming problem for the problem where we are using the primal simplex method. Okay, that's all. Now come to the problem. See, I have told if you find solution is integer, fine. If it is non-integer, so cutting plane. Okay, the cutting plane will help you. So we'll add some secondary constraints using the cutting plane. So then the cutting plane will force the non-integer solution toward the integer solution. The constraints what you are adding using the cutting planes can be formulated in this manner. See, cutting plane means we are putting some constant. Okay. For example, okay. So you see when you join IIT in the, let us say, in the Department of Computer Science, you have many options. What are the options to you? So you'll go for higher study, number one. Then you will search a job, let me say, in a very good software company, or you will be a teacher in some IIT or NIT or somewhere else. Okay, or you will have a farm or something. So many options are there. So the feasible region, feasible region. So decide what is the feasible region. Now, your friend or mother or father has imposed some restriction. What is the restriction he has imposed? No. So whatever you do, but your monthly salary should be 1 crore. Okay, your monthly salary should be 1 crore. I have heard from many people, many IIT people that, the students of computer science, they're getting good salary. The salary, very good salary. The salary amount is at least 1 crore. Okay, that is the restriction. So now if put that restriction, what will happen? Certainly, you will not be a teacher. Yes or no? You will join certain, or you will have one startup or something. So you will not go for higher study, or so you will start your own path, everything. So maybe in some good company you join. Okay, then your salary will be 1 crore. Okay. So now what is happening? See, once you put some restriction on that, so whatever you are interested to achieve, it may achieve. Okay, it may achieve. But so achieving, you should be capable. Okay. For example, you are a computer science student, but your CGPA is 6.5. Nobody will offer job of monthly package is 1 crore or annual package is 1 crore. Nobody will give. Okay, I am sure. Okay. So from your CGPA, so it reflects that you are a IIT students, but no doubt you are not a very excellent student. So CGPA, CGPA. So without seeing your CV, from your CGPA, one can guess something. Okay, one can guess something. See, almost all the good students are, CGPA is more than 9.5. 9. Okay, fine, no problem. But I'm telling, see, so what my thing is, once you put some restriction, the restrictions are nothing but the constant. The constants are we are expressing in terms of what? Linear constants here in the linear programming. But when you go in the real life, the constants are not linear, they are non-linear. Okay, non-linear. So mathematically very difficult to express such constants. Okay, right? See, I said something, say verbally. So you cannot express my constant, my restriction in terms of linear equation in equation, right? Okay. So they can be non-linear, they can be something else. Okay. Because today my voice is something, tomorrow I will say something else. Okay, right? See, your parents are saying, no, your annual package or monthly package should be 1 crore. After 2-3 years, they say, no, it is not possible. Okay, so leave that one. So any job will be all right. Okay, even Google job is all right, or Microsoft job is all right. Okay, right? But I observe people got very good job, very good package. After serving 10 years, 5 years, again they just started from the beginning. No, sir, I should do for PhD. Can you give me a recommendation? They're asking. So, but that mistake you don't do. Finish whatever you like in the very beginning. Okay, and mere BTech qualification is not enough. Mere BTech qualification is not enough. You should go for higher study. For higher study, the one place you know where you should go for higher study. Okay, so and if you have a mind that yes, I should go for higher study, I should learn more. Okay, so then USA is the only place where everybody on earth. So everybody will recognize, yes, right? So, but what I'm saying here, so if you have planned for higher study, start in the very beginning and not after 10 years. Why 10 years? No, I have earned a lot of money, now I should go. Not that. Okay, do it at the very beginning. And if you can achieve something, you can develop something of your own, maybe one page or one line. So that is, that people will remember. But if you do thousands things copied this, that, so nobody will remember, right? Okay, thank you. So now these constraints will force the non-integer solution toward the integer solution. Okay, how? So now answer is like this. See, generally I have told in a linear programming problem, this, the parameters are Cj, then we have parameters like Aij and Bi. With respect to Cj, Aij, Bi, we have a simplex table. That simplex table for the primal linear programming problem is called initial simplex table. So initial simplex tables in terms of Cj, Aij, Bi. Okay, but after few iteration, so maybe in second iteration or third iteration and fourth iteration or last iteration, this Cj, Aij, Bi will not be there. You will find new value. Okay, the new value, let us say I'm saying Aij will be something like alpha ij, Bi something like beta I. The value will change, yes or no? Who can say? Value will change or remain same? After few iteration, value will change. Okay, A11. What is A11 stands for? A11 stands for in the first inequation or first constants, first row, first column, A11. Okay, in the last table, first row, first column will not be A11, it's something else. Yes or no? So
Yes, sir.
that is the things we are finding and we are observing at the last iteration. This alpha A11 is becoming alpha 11, A12 is becoming alpha 12, A1j is becoming alpha 1j, and similarly B1 is becoming beta 1, and A21 is becoming alpha 21, A22 is becoming alpha 22, etc. Okay, right. Now the C for A we are replacing as alpha, for B beta, and C we are not replacing. You can say gamma also, but I will tell you why we are not replacing. C only to recognize. Okay. Now I have told repeatedly, use condensed simplex method. The problem what you have taken, a linear programming problem, n number of variables, okay, m number of inequation, constants are all less than equal type, right hand side b1, b2, bm all are non-negative. So you use slug variables as basic variables. How many slug variables are needed? How many slug variables? There are m number of slug variables. The slug variables are we are naming as S1, S2, S3 up to Sm. Yes, these are the slug variables. The slug variables are known as basic variables. Initially, how many variables were there? There are n variables, and the slug variables are basic variables. Altogether, how many variables? M plus n number of variables. Yes? Yes or no?
Yes, sir.
Now, after applying the simplex operation, at a particular stage, we declare that the solution is optimal. Under what condition we say solution is optimal? If you are using primal simplex method? Yes, anybody? Under the what condition we say that the solution is optimal? All the Zj minus Cj, all the indicator row elements has to be non-negative, 0 or positive. Yes or no? And the decision variables. So as I told, B1, B2 are non-negative. If it is feasible, has an optimal solution. So this is the, here in this problem, no artificial variables, no surplus variable, only slug variables. Okay, because we have taken a problem. What type of problem we have taken? We have taken a problem like this. So maximization type objective function, constants are all less than equal type, Bi is non-negative. Okay, so this is the scenario here. Now I like to, and this table whatever is given, let me say this is called optimal table. Optimal. In the optimal table, how many basic variables will be there and how many non-basic variables there? Who can say?
There will be
There
M.
are m number of m in equations, m number of basic variables. The basic variables are BV. In short, we are saying BV, x1, x2, x3 up to xm. See, this basic variable will not appear serially. Let me say it is appearing serially. See, sometimes if you are solving problem, first you will say that x2, then x1, then x3. So let me say in some ideal case, we have x1, x2 up to xm are the basic variables. Okay. Then what are the non-basic variables? Non-basic variables out of m plus n variables, these series basic variables are x1, x2 up to xm. The non-basic variables are rest, the complement. My non-basic variables, how I will name? I am naming in this manner. My non-basic variables are W1, W2, WJ up to WN. Altogether, how many variables? So n number of basic variables, m number of basic variables, and n number of non-basic variables. Total number of variables are how many here? M plus n, right? In some table, we display all the columns, m plus n columns. For which method we display all these m plus n columns? Which method? Who can say? I have taught you recently. Which method? Buddy? Buddy is there? Buddy, tell me. Some students asked me that they want to do some summer project or something like that. I am ready to take, but you have to do the work and you have to show me. Okay. And every week at least you will even phone also, over phone, what you have done, you have to present me. Okay, that's all. If you can do, then it's fine. Okay. Which method all the m plus n number of columns we display?
So revise simplex.
Yes, revise simplex method. But I told revise simplex method we use, but revise we display all the columns for some other reason. But here we are not displaying all the columns. Only we are displaying how many? We are displaying only so n number of columns for non-basic variables. Okay, of course, for the basic variables are there already m rows. Okay, that's all. So and here, since you know x1, x2 up to xm, these are the basic variables. The coefficient of the basic variable x1 will be how much? Initially, what are the coefficients? C1. What is the coefficient of x2 on the objective function? C2. And coefficient of xm, Cm. But after so many iteration, which one is the okay, and what is the coefficients? We do not know. Okay, but these are the name of the basic variables. I am naming only. They are not the actual basic variables. They are the actual decision variables. They are the so we are naming this basic variable in this manner x1, x2 up to xm, and their coefficients you can write here. But I am not interested for the coefficients. Okay, so the coefficient I have put star mark here. I don't know, and similarly coefficient of x2 is also unknown. Okay, unknown means so cannot be spelled out correctly. Okay, this. And since it is optimal, our Zj minus Cj, j equal to 1 to n, they are non-negative. Z1 minus C1 bar. Z1 minus C1 initially that is either 0 or positive or negative. But finally, this is the optimal table. All has to be non-negative. Z1 minus C1 bar, non-negative. Z2 minus C2 bar. The bar sign means the optimal case. Okay. Z2 minus C2 bar, non-negative. Similarly, Zn minus Cn bar is non-negative, right? This x1, x2 up to xm, they are the basic variable, m in number, and w1, w2, wn, they are the non-basic variable, n in number, right? Okay. Is there any confusion in this table? I will tell you how many of you are using my table and how many you are borrowing from the textbook. Anybody is borrowing from the textbook? If you are borrowing from the textbook, so there will be problem. What is the problem? You will learn that method and you will learn this method. So you will have a hybrid method. Okay. So better either you follow the textbook or you follow me. Okay. So then it is fine. because answer will be same. Okay, but if you follow me, so you have to follow these methods. If you are following textbook, something else is there. Okay, that is all right. So are you finding some table very similar what we are discussing? Okay, in textbook, are you finding? I hope you are not taking the breakfast. Okay, I have also not taken. Have you taken breakfast? What is the time now? Okay. Okay, this. So before going to the next step, I will tell you if this table, this is the table, we say it is optimal table for the linear programming problem. Now, what about the beta 1, beta 2 up to beta m? This says the x1 value equal to beta 1, x2 value equal to beta 2, x3 value equal to beta 3 and so on, xm value equal to beta m. Okay. So what are the value of the non-basic variables? Who can say? Anybody?
0.
Non-basic variable?
They're all set to 0.
All are 0. Okay. We don't bother about the non-basic variable. Non-basic variables all are 0, right? But this beta 1, beta 2, beta m all are integral. Then what happens? No need of thinking about cutting plane. No need of thinking about cutting plane. If you find beta 1 is integer, let us say beta 1 equal to 1, beta 2 equal to 2, beta 3 equal to 5, say beta m equal to 10. Okay. So integers. So if it is integer, stop here. No question of going next step. Okay. If you find some of them or few of them or all of them are non-integer, then the crisis, there is a crisis to develop cutting plane. Some additional constants. How will develop? Let us know. So here beta 1, beta 2, beta m, let us say all are non-integer or few are non-integer. So we will find which one, whether beta 1 or beta 2 or beta m, which one has a largest fractional part. For example, beta 1 equal to, I am taking 2 only, beta 1 equal to 2 and half, beta 3 equal to 3 and 1/3, beta 2 equal to 3 and 1/3. So among beta 1 and beta 2, which has largest fractional part? Beta 1 equal to 2 and half and beta 2 equal to 3 and 1/3. Which has largest fractional part?
Beta 1.
Beta 1. So fractional part, we are talking about the fractional part, which has largest, so beta 1. So now, then what will happen? We will consider beta 1. If beta 2, for example, beta 1 equal to 2 and half, beta 2 equal to 3 and 5/6, which has largest fractional part? Beta 2. Beta 2 will consider. Okay, accordingly. So if you don't mind, I will take 5-minute break, and in the meantime, all you are in hostel or in the house? I think almost all. I heard that class will start, the offline class will start very soon. Okay. Yes or no? Okay, another thing is, so today I have class in 2 hours, then tomorrow 1 hour. So I have some urgency to go somewhere, okay, for some medical reason. So I want to take 3 hours, maybe, and I'm telling maybe 2 hours in Wednesday and in Thursday 1 hour. In the evening sometimes I'll complete, means 1 hour class in the advance I can take. Is it possible? If you agree. And the timing maybe say 7 to 9, Wednesday 7 to 9, and the Thursday again 7 to 8 in the evening. Is it possible? If it's possible, say yes. If not possible, then very difficult, because once I'm going out, the facility will not be there to take class, because you know the net connection will not be there, then the power will not be there. So you know, once you're going out, so I'm helpless. Okay, that's all. So I will take 5 minutes break. Okay, then we'll join. Right? Is it all right? Okay. You please in the meantime also if you like to take something, take. And okay, thank you. There was problem. Okay. Are you able to hear? Hello?
Yes, sir.
Okay. Others Goel? Is there? Akshat Sharma? Nitin Patel? Parikh? Gauri? Nikita? Ishita Agarwal? Bhavesh Jain? Pradyumna Bansal?
Present, sir.
See, if you are not coming, if you are not coming regularly, I may deregister. Please remember, I am very serious. You are not attending class means I will deregister. You will suffer at the end. Okay, and one more year you will stay at IIT Kharagpur. Okay, please remember. Anmol, Rajesh Chandra Jha, Shesh Senai, Shivashish Das, Apurva Rai,
Present, sir.
Sashish Maurya, Shivam Rajesh Gupta, Soumyadeep Nandi, Azad, Jitendra
Present, sir.
Okay. Akita Jajo, Ayush Prasad, Adhiraj Rastogi, Aditya Singla, Lakhyat, Shailesh Soni, Shashank Singh, Simran, Sumit Kumar Agarwal,
Present, sir.
Tushar, Vital Agarwal,
Sir, Vitthal
Priyanshu
Agrawal
Pandey,
present.
Aman. If
Sir,
you are
Priyanshu
able to
Pandey
tell me
present.
yes, sir. Okay, that is enough. Tanishq, Nandakuti, Hari, Harsha,
Present, sir.
Naresh Kumar, Utsav Val,
Yes, sir.
Tushar Kumar Mishra, Piyush Kumar, Alak Dikit, Avranil Das,
Present, sir.
Nirmal, Shwasat,
Present,
Julia,
sir. Present, sir.
Ishita Jhunjhunwala. Only they join in the course but they will not come to the class. Ayush Mishra, Sachin Agarwal, Urbi, Harsh Kumar,
Present,
Akshat
sir.
Sharma,
Present.
Tushar,
Present, sir.
okay, Aditya Tiwari, Akash Agarwal, Aman Datta, Anil Kumar Jogi, Arya, Aishik Das, Ayush Dak,
Present, sir.
Ayush, Chintapati, Venkat,
Present, sir.
Jitesh Bansal, Piyush,
Present, sir.
Sunil,
Present, sir.
Deep Raj Brahma,
Present, sir.
Shansu Singh, Devjit Chaudhary,
Present, sir.
Gadam Jogesh,
Present, sir.
Jain, Gautam Singla,
Present, sir.
Jasprit Singh, Jaya Kedia, Karan Upal, Krishna Naik,
Present, sir.
Kirtika,
Present,
Malath, Dilip.
Present, sir.
Okay. Ragne, Manusani Vaishnavi, Venkat Sri, NCJ
Present,
Rahul
sir.
Reddy, Nishant Goyal,
Present, sir.
Pradyumna, Manoj Kumar,
Present, sir.
Parv Maheshwari, Patel Silas,
Present, sir. Present, sir.
Pulasai,
Present, sir.
Rapul Reddy,
Present, sir.
Prakash,
Present, sir.
Bhaskar,
Present, Sankla.
Pratibha Biswal, Rahul Saini, Rampriti Tridev,
Present, sir.
Ratnesh Khandelwal, Rishabh Agarwal, Rishit Singhania, Rohit Deshpande.
Rohit Deshpande, present, sir.
Yes, thank you.
Present,
Rashid
sir.
Kumar, Sagnik,
Present,
Chauki
sir.
Trivedi, Chauki Kabra, Sudhanshu Ranjan, Sugali Krishna Kumar,
Present, sir.
G. Rudra.
Present, sir.
Okay, somebody is calling. I'm just coming.
Sir, you are on mute.
Sir, you are muted.
Sir, you are muted, sir.
Sir, we can't hear you. Sir, we still can't hear you.
Sir, you would need to open the Teams and unmute, sir.
Okay, this is gone. Okay, if you are not doing fine, you are not coming to class, you are not submitting, then I don't know why you joined. Only mathematics students are enough. Umang Pandey, Ayan Kumar, Jatin Saini, P. Tejasvi, Aditi, Nihal Kumar, Abhay Kumar, Shunita,
Present, sir.
Anant Manoj Kumar, Ashish Rekhani.
Sir, Anand Manoj Kumar present.
Yes. Ashish Rekhani, Buddha Mohan,
Present, sir.
Krishna Venkat, Dasari Giridhar,
Present, sir.
Kunchela Chandra,
Present, sir.
N. Surya Prakash Reddy,
Present, sir.
Pentam Sethi, Prakhar Singh, Priyanshu Dikshit, the computer science student.
Yes, sir.
Okay.
Present, sir.
Kasrat Naidu,
Present, sir.
Shiva Maharaj. Among the computer science students, anybody has answered all the three questions correctly? From serial number 118 to how many are there? 18 to 162. Around 45, 48 students are there. Okay. Anybody has answered correctly all the three questions? Anybody? Computer science students? If you cannot answer, how the other student will answer?
Sir, for the third question, time was not sufficient.
Yes,
You
sir.
are doing no. IIT students are doing group work. So your group work didn't work because all you are doing group work. Always all the discussion, everything in group. Why here group work fail? Not that, because you have not prepared properly. The
Sir,
last question was from the revised simplex method. Yes or no?
sir,
Sir, actually, 3 answers were coming to be infinity in the test, and we didn't know how to.
You want the answer?
Sir,
I will
I
give you
got
the answer.
infinity as one of the answers, and I
Okay.
how to
It's
type it.
whatever, if anybody has got infinity the answer, you work out clearly and send the PDF file to me. Okay, right? PDF file. So
Sir,
I will not give
actually,
the
I
answer.
don't have
After
the
getting your
questions.
answer, I will discuss. Okay, whether it is mine is wrong or right. Okay, right? So you
Can you share the
clearly
question?
work out correctly and send me the answer in the PDF file. Okay, to me, email ID. Okay, right?
Sir,
Fine. After that, I will disclose how much mark you got. Okay. Now I have not. If, for example, you are right, I am wrong, so you will get full credit. No problem. It may happen. It's quite possible. Mistake will come everywhere. No mistakes. Okay.
Sir, I had a request. Can you share the question paper because we can't access the questions of the test. So how will we? Means I don't remember the exact values.
Can you?
Share the questions with us. Means because I don't exactly remember the values.
Oh, the question paper. I will give the question paper. I will send the question paper to everybody. Okay, right?
Yes, sir.
Sir,
Today
in
itself I will
Moodle
give-
you can allow
No,
review
no, I
so
have the
that
hard
we
copy.
can.
I have the hard copy. I will send the PDF file to everybody, right? Okay, that will be fine, isn't it? Okay, so even not only that, even the old question I have, if somewhere is there, I can send. But problem is, during the pandemic, so I have 3-4 computer, 3-4 laptop. Okay, so where I have kept, I have to recall, and for recalling that, I have to make some record. Okay, you see, today I have saved in a pen drive. After 6 months, that pen drive is not working, and I have put somewhere in the Google Drive. Okay, the Google nowadays is creating problem. He's saying that you are the same MP Biswal, so he's merging all my, and at a time I can only open one ID. So many problem. Everybody is creating problem. Okay, so the world is problematic. Not only I have email ID something like 22, 21, 20, 18, 19 like that. Every year I am creating one email ID. Why? Why I am creating? Because so a lot of files I have dumped, and the same file is repeating, but sometimes I am not getting. Okay, so it is fine, but sometimes recently this a problem, that PDF file is there with me because I have saved somewhere, and today itself I can send it. Okay, and the answer also I can send, no problem. Okay, so but what I'm saying, you try, whatever the code you are writing, you preserve it and show me, sir, this I have done it. So I will be happy if somebody discuss, yes sir, I have done, and what is the mistakes you have committed. So sometimes I will tell, sometimes I will learn from you. This is a new things you have developed. Okay, right? Research teaching, whatever the new things should come now, something new. Okay, some shortcut method, some useful method, right? But you are not coming, not visible, not coming to class means it is a crime. You are at the hostel or at the residence? Tell me. Anybody in the residence? Anybody in the hostel? Anybody? How many of you are in the residence and in the hostel now? Almost all you are in hostel. Yes or no? You see, you are staying in the hostel. All facilities are there. You are not attending the class. So then it is a crime. I'm telling. It is a crime. So crime means you are not coming, and sometimes you are not informing your parents that you are not attending the class, but you inform your parents that I am not attending the class. So I should not call because I have the capacity to call your parents. I will not call. Why I will not call? Because all my time will go on useless work. If somebody say that yes, somebody is vanishing from the class and he's not coming, I can. See, last year I was taking a class. Somebody has passed, again he doesn't know whether he's passed or not. Means he's not checking the result. He told, I want to, this year I should take. I told him, you have already passed. I have remembered. And pass means I have made you, you have failed, I have made you pass. So that's my work will be simple. The P grade is the punishment grade. See, if somebody is getting P grade, then so that it is a punishment. So this P grade will not help anything in any way. At least a good student should get something like A or excellent or B. Below B, it is meaningless. I'm telling you. The C grade is nothing. So IIT pass mark is C. If you are getting more than 6, then you will have the degree from IIT. So you should need degree in a grade like A, EX or A or B. C is meaningless. So C is meaningless, P is meaningless, D is meaningless, something like that. Okay. So what I'm saying here, you should learn the subject properly and you should reproduce in the class. Where I stopped? Okay. See, I will not take for any more attendance because my ultimate goal will be, it will not achieve. So if you have done, any coding, yes.
Sir, you changed the meet, so you missed my attendance. Kirti, 59.
50?
Kirti, 59, sir. You changed the, meet got changed, so we were in the previous meet.
No, okay, all right. Because I was, I was in the. So you are not able to join or any problem?
So I was joining this and it got late and you missed my attendance in that.
See, I am just calling to know how many are there. I am not taking the attendance. I am just calling how many are actually there in the class. Okay. I am not taking attendance.
Okay,
I don't bother for the attendance.
No problem.
But I want to know how many are there. How many are really attending my class.
Okay, sir.
So
Thank
that
you,
is my ultimate, see, I am taking class for 160, I am claiming, but finally there will be 10 students. That is not fair. So henceforward, I am telling, if you are in the station, you attend. So if suppose 8 o'clock class is not possible, then we can change the timing, but it is better to remain in the timing. Okay, because so that somebody is there in authority checking whether I am taking the class. My slot is 8 to 10, but I was not there in the 8 to 10. So it is not fair. Okay. So as a IIT student or IIT faculty, it is not fair that I should not attend the class. I should attend. Okay. I have taken the money, I'm getting the salary. I should do the work. So this, see, I'm telling once again, I am sending the, and I have told there also earlier. So if you have not correctly answered the question, you work out again and send me individually your working procedure to me. So let it take say 2 hours, no harm, but you should know the answer. What is the answer? And send directly with your own handwriting. And don't copy it. I'm telling. So in USA, my son, my daughter told you, even if a problem is given, nobody copy. And see, I asked, what is the grade you are getting? Their university say that nobody should know what is your grade other than the teacher. Whether you are getting excellent or a, nobody should know, and nobody should share. Say what is that? Your answer. All are doing homework. Homework is a part of that. Okay. So you should do your homework individually because it is given. So you have to reproduce the answer. Whatever. So 7 days or 10 days or so if you are very smart, so within say 1 day, if somebody is not smart, it takes 7 days. Okay. But you should do yourself, but don't copy from others. So similarly here also you should try, and if any difficulty you should ask me. Okay. So asking me, you take my permission and ask, I will tell you. Okay, but I'm telling sometimes, in the mutual discussion it helps. But mutual discussion means what is the mistake I have done? Somebody will say. But you are borrowing his answer directly, and sometimes people they borrow somebody writing roll number, same roll number also they borrow. See, people are not fool. They will check everything. Okay, so if whatever the code you have done, you have developed only one code, you send it to me. So I will check how many are doing and how many are not doing. See, for the coding, I have kept some mark. Okay. So why I have kept mark? Because the good students should get the benefit. A poor student should not get the benefit. Okay. And X has developed. So he want to get benefit. I will ask him how you have developed, you explain me. Okay. But if somebody has not developed, he cannot explain. You send it, I will ask question. I will give some time. You be available. I will ask some question. That you should do it. Okay. So, and you don't spend the entire amount of time with the OR. Only spend weekly 3-4 hours. That is enough. Okay. Okay. I will not take. So if you have done, send to me. And if you have not done, you try to do. Okay. So for the, I'm keeping, why some date is there because 3 program. Okay. You do at times 3-4 programs and send. Okay. That is all right. So where you stopped, can you remember? Integer programming. Okay, here. This is the optimal table for what? For the linear programming method. At the optimal, once a table is optimal, so we declare the solution and value of the auxiliary function is z bar, x1 equal to beta 1, x2 equal to beta 2, xi equal to beta I, and xm equal to beta m. All the non-basic variables are 0. Clear? Okay. Now, if you are expressing something, how will express? I will express in this manner. Please, with respect to first basic variable x1 plus alpha 11 into w1 plus alpha 12 into w2 plus alpha 1j into wj and so on. Finally, plus alpha 1n, okay, say 1n into wn plus this all the terms, all the n plus 1 terms equal to beta 1. Is it all right? Similarly, x2 plus alpha 2 into w1, alpha 2 into w2, and so on, alpha 2n into wn equal to beta 2. Like this, you can write yes or no. Same thing I am expressing here in this manner. See, this beta 1, beta 2, beta up to beta m, these are non-integer. If it is integer, nothing to do. Let me say one of them or some of them or few of them are non-integer. Okay, if we are finding non-integer, we select a beta which has largest fractional part. So let us say beta I has the largest fractional part. With respect to beta I, you can write in this manner: xi plus j varies from 1 to n alpha ij and wj equal to beta I, where beta I is greater than 0. Can you write in this manner? This beta I has the largest fractional part. So this part, and here since our xi equal to beta I is non-integer, so this is the outcome. Anybody has any doubt here? I am ready to explain repeatedly. If you need 100 times, I can. Is all right? I am again moving to the table. X1 plus alpha 11 into W1 plus alpha 12 into W2 and so on, plus alpha 1 and W1 equal to beta 1. In similar manner, we are writing, since this xi is non-integer and it has the largest fractional part, so we write xi plus summation over j varies from 1 to n alpha ij into wj equal to beta I. Beta I is non-negative. Is it all right? Anybody has any doubt? Tell me.
No.
Say doubt is doubt. If you have doubt, means it is a good thing. Your memory is working and you are working. If there is no doubt, means you are not working. You are sitting. You are dull. Your mind is not working. You should have some doubt. Is it all right? Of course, may not be in here. Is it all right? Tell me something. Should I move ahead? Okay. So here, just see, I have told this beta I has the largest fractional part. How do I write beta I? Beta I, let us say beta I equal to 2.5. Then we can write beta I, okay, beta I equal to the integral part of beta I, this function, what do you call? The greatest integer function. This is the symbol. Beta I equal to integral part of beta I plus the fractional part. Yes or no? Beta I equal to integral part of beta I plus the fractional part. And what about the fractional part? This fractional part fi is less than 1 and greater than 0. Since it is a fractional part, half lies in the interval 0 and 1, 1/3 also lies in the 0 and 1, 2/5 also, right? So similarly, with respect to alpha ij, we can write alpha ij equal to alpha ij, its integral part, plus fij. This fij is less than equal to fij, means fij less than 1 and greater than equal to 0. Why? See here, in the first case, fi lies in the interval 0 and 1. In second case, so you know that is a open interval. But here in the second case, alpha ij equal to integral part of alpha ij plus fij. This is, you know, one side closed, one side open. Why it is so? Who can say? This fi lies in the interval 0 and 1, open interval. But this fij lies in the interval 0 and 1, but one side is closed, other side is open. Why it is so? Who can say? Anybody?
Sir, beta is not a perfect integer. That is why fi can.
Beta I is not a perfect integer. But here, there is nothing mentioned about alpha j. It can be integer, it can be non-integer. Okay, it can be positive, it can be negative. But this beta I is strictly positive and it is non-integer. We have selected and we have said it has largest fractional part. So that is the right answer. So fi lies in the interval 0 and 1, but alpha ij, also in 0 and 1, the right hand side is open and left hand side is closed, right? Here a simple example, you know also, again I am repeating. So the integral part of k, if k is fraction, let us say integral part of k is less than or equal to k. This is the greatest integer function what we are using. This, and now it is there in the integer programming. You can see here, integral part of 2.5 equal to 2. This implies half plus 2 equal to 2.5. Is it all right? Integral part of minus 3.5, how much? How much? Integral part of minus 3.5, who can say?
-4.
Minus 4. But for plus, it is, less. For minus, so minus 3 is minus 4. Okay. And similarly, you can write this is as half minus 4. Okay. But please remember, this fractional part is always what? Is always positive. Integral part can be positive, can be negative, but the fractional part is always positive. Okay. This is half minus 4 equal to 3.5. Okay. Similarly, so what is the integral part of plus 5? 5. Integral part of minus 5? It is minus 5. So where there is a difference, 2.5 integral part is 2, minus 3.5 integral part is 4, and so on. Okay, that's all. So with this we'll proceed. Okay, all right. Now it is very interesting in the sense. So we are going to achieve something from here in this equation. This is equation or inequation? Xi plus summation over j plus j varies from 1 to n alpha ij wj equal to beta I. So how many terms are there? This is first term is xi, then there are say n terms, n plus 1 terms left hand side, and the right hand side only one term beta I, right, which is non-integer. Okay, what we are going to achieve? Okay, see the next slide. We are not talking anything about xi. See, this alpha ij, as you know, it can be integer, it can be non-integer, anything, but beta is clearly mentioned, beta is non-integer, positive non-integer. This alpha I can be anything. So we are replacing using the greatest integer function. This alpha ij, so wherever the alpha ij, we are writing the integral part of alpha ij plus fij into wj. Earlier it was something like this, alpha ij into wj. So in place of alpha ij, we are writing integral part of alpha ij plus fij. Similarly, instead of beta I, the right hand side, we are writing integral part of beta I plus fi. Can you write in this manner? Please check. Can you write?
Yes.
We can write. Now, see, some are integer, some are non-integer. See, we want xi to be integer. We want xi has to be integer. So if you find xi, presently xi is not integer, but we want that xi has to be integer. Okay. So what we should do? Keep one side everything integer and other side everything non-integer. Okay. So xi will make xi, presently we don't know. So in this case xi is non-integer. So this xi I am keeping in the left hand side. The beta I is integral part. So we are bringing to the left hand side. As a result, there is minus beta I, that is bracket function, bracket of beta I, plus summation over j varies from 1 to n, the bracket of alpha ij into wj. Okay, this is integer. All the integer I have keeping one side, other side what? Fi minus summation over j varies from 1 to n, Fij into Wj. This we have written in this manner. Is it possible to write? Is it possible to write? See, I have told you earlier, Fij, this Fij lies in the interval 0 and 1. The left hand side is closed, right hand side is open. So the Fij is fraction. Fij is fraction, and also Fi is fraction. And what about Wj? In a linear programming problem, basic variable and non-basic variables all are non-negative. All the variables are non-negative, whether it is basic variable or non-basic variables, all are non-negative. Yes or no? Basic variable, non-basic variable, all are non-negative. Since all are non-negative, so Fi minus J varies from 1 to n, Fij Wj, this quantity, what we will find here? This quantity is non-negative. Sum of all the terms, J varies from 1 to n, Fij Wj is non-negative. See, I am telling here. So, Fi, let me say Fi equal to 2.5. 2.5 minus some quantity. Okay, some positive quantity. 2.5 minus some positive quantity is less than 2.5. Yes or no? Fi minus some positive quantity is less than Fi.
Yes, sir.
Okay, because you have subtracted something. So same thing here. For all Xi, Wj, the LHS left hand side of this expression is integer. Hence, right hand side is also integer. Left hand side integer means right hand side integer. And what about the right hand side? Fi minus summation over J varies from 1 to n, Fij Wj. This is actually less than or equal to, because we have something like this, you know, the Fij is less than 1, greater than or equal to 0. If all are 0, what will happen here? The equality sign will come. So it should be less than or equal to Fi. But what about the Fi? What about the Fi? Fi is a fraction. See the definition. This Fi is fraction, lies in the interval 0 and 1. Okay. So from here we observe. So this is less than or equal to Fi. Fi is less than 1. The last line is correct. If you accept, then I will conclude.
Sir, how is LHS integer? Can you explain? Because Xi can be anything.
We want that the variable at the when we get a solution, final solution, optimal solution, my Xi will be what? Integer.
Yes. Yes.
Unless it is integer, we will not stop. We will continue. Okay. Let me say Xi is integer. Okay. So with respect to that, we are doing all the things. Okay. So Xi and all the integral part we are bringing to left hand side. All the non-integral part right hand side. See,
Okay,
the first,
sir.
so all integer together, their outcome is integer, plus minus. All the non-integer plus minus has to be also. If left hand side is integer, right hand side has to be integer. That is the things. Nothing else.
Sir, Wj is integer.
They are basic variable, non-basic variables. Okay. So in the table you can see at an optimal stage what has to be here, x1, x2 up to xn. They are the value beta 1, beta 2. Okay. If beta 1, beta 2 up to beta m, they are all becoming integral value, will stop. So I have taken a case where beta 1, beta 2 up to beta m, they are not, all are not integer. Okay, some of them are non-integer. Okay, right? So the basic variable, non-basic variables. Basic variables are always we can express in terms of it is given x1 equal to beta 1, etc. But non-basic variables are what? W1, W1, they are actually 0.
Yes, yes, sir. Okay.
In the table they are 0. But
Yes.
you see, But when you are expressing a equation in terms of equation from the table, we will write in this form. So xi plus summation over j varies from 1 to n, aij wj equal to beta I. But you say wj equal to 0, then xi equal to beta I. Other information where is gone? All the information we are taking together. Because you see, presently they are non-basic variables. Okay, so we are expressing, so that means of the greatest integer function. So what will happen to the outcome? The outcome is like this. Okay, so this, and finally the left hand side is integer, right hand side has to be integer. So fi minus this is less than or equal to fi, and which is less than 1 because it is given fi less than 1. It is this expression is less than fi and which is less than 1 and integer. Then what is the outcome? You tell me. This quantity fi minus this is less than 1 and integer. Less than 1 and integer. Which quantity is less than 1 and integer? Tell me.
0 and
0. That is the right things. Now, same thing we are writing. So this has to be, therefore, fi minus summation over j varies from 1 to n, fi wj is less than or equal to 0. Okay. So this equal to summation over j varies from 1 to n, fi j wj greater than or equal to fi. If I am expressing in this manner. Okay. Now, this actually, this looks like a constraint of a dual program, not primal program. Yes or no? This looks like a constraint of a dual program, not primal. For the primal, constraints are less than equal type. For the dual, constraints are greater than equal type, right? So now, if you are going to solve, what will do? Multiply minus sign, okay? Then it is less than equal to minus fi. Then you have to add some slack variables, okay? Summation of j varies from 1 to n, fi j wj plus si equal to minus fi. This. So this, once you are using this one known as a cutting plane, a fractional cut. So this constraint has to be used in the previous program, previous table, and we have to solve the problem. This fractional cut may be added in the last simplex table. This is the actual cutting plane. Say, when you solve a problem numerically, what is the cutting plane? I will explain you. Okay, here, this is the things. So first line is clear in this slide. Therefore, this is correct. Second line is clear. Third line is clear. If you say, then I will move to fourth line. Okay. See, all the, all we have the similar type of brain because you have qualified JE. Okay. And all you are reading, let us say computer science, same category. But you should be able to realize, able to justify, and able to work together alone also. Okay. So try to realize that yes, it is understood. If you say yes, then I will move. Okay. No question of no. Everybody can do. Okay. Say a poor students can be also a brilliant students, but it will work. But generally, many people they don't know how to work. Okay. Because working is a difficult job. So relaxing is a simpler job. A small problem, if you are working, sometimes if you commit a small mistake, it takes hours together. But if there is no mistake, so quickly you can solve. But you commit mistake. But generally, one has to be very cautious when you solve problem. Okay. And your mistake, certainly you cannot find out. Somebody else. So you consult your friend. What is the mistake I have committed? I am unable to do it. But if you are doing in group, you ask your friend. So please check my mistake. I am checking your mistake. Okay. So your friend can find your mistake and you can find his mistake. So that is the group work, you should do it. But somebody has copied and I will say I'm sharing the answer. That is not fine. Okay. For me, it is not fine. Okay. That's all. And you must have seen, see, when I am teaching, you have pointed out some mistakes. I'm happy because mistake generally the listener should find out. Okay. Because if he's listening or if he's watching the slide properly. Okay. This is all right? Yes or no? First, second, third, fourth line, 4 lines are there. Is all right or not? If somebody says no, then I will again start from the beginning. If you say yes, I will proceed. Anybody say no? If you are saying no, why it is no? If you are saying yes, certainly it is clear that you understood. You see, somebody here when you are concluding this quantity less than 1 an integer. Less than 1 an integer. So less than 1 an integer. Say somebody said 0 and somebody said -1. -1 also answer less than 1. Okay, an integer. So -1 also less than 1. So 0 is the ideal in the sense because they what you are saying here, because this is quantity less than 1 and integer. So 0 is ideal. Okay. Right? And you can say -1 and try what is happening. Okay. So this one is equivalent cutting plane of our problem. And this should be added to the last simplex table and solve. Now the question is, so we will not work out from the very beginning. Only one row you have to add and solve. Okay. This problem may be solved using dual simplex method. Dual simplex method. You have heard the name dual simplex method? Have you heard the name? Because you have solved several problems.
Yes,
okay.
sir.
Dual simplex method. This procedure is repeated till we find an integer solution. We'll continue this process till you find an integer solution. Okay. So now what I will do? So for a few minutes I will talk about the dual simplex method. Okay. These slides I have given to you. If not, I will again send today. This problem you can solve using dual simplex method. Okay. How to solve? This is a problem which cannot be solved by primal simplex, dual simplex. Yes or no? The D1 I have put knowingly, it is related to the dual simplex. Okay. How will solve? You multiply minus sign. Okay, with the two constants. The constant can be expressed in this manner. Then introduce log variables. Then apply dual simplex method. Right? This I told you earlier. I don't know. So why you are not responding?
Yes, sir. Yes, sir.
See, I am shouting without taking breakfast. You have also not taken breakfast and you are not shouting. You are not even answering. Okay. So this and other thing you know. So once you have got this, you can apply the dual simplex. I will not. So I will give you the table. You okay? Use the table and conclude. Okay. This. Now second problem. You see here. Earlier is 2 variable problem. Second one is 3 variable problem. Can you solve using primal simplex? No. Here also dual simplex method is applicable. Okay. So multiply minus sign and proceed in the similar manner. Okay. You know it. So I have not again. Okay. So this third problem, D3. What do you observe here? One constant is less than equal to type. Other constant is greater than equal type. But please remember, in the dual simplex method, we don't use equal type constant. If a equal type constant is given, you have to make two equations. One is less than equal type, another is greater than equal type. For example, x1 plus x2 equal to 2. First constant will be x1 plus x2 less than equal to 2. Second constant will be x1 plus x2 greater than equal to 2. Their intersection is 2. Okay, x1 plus x. Okay, that is it. So here, one constant is less than equal to 18, other is greater than equal to 6. Okay, like this. One is less than equal to type, one is greater than equal to type. So which method will apply? My 3 mathematics students, then
Yes.
I will ask computer science student. Which method will apply?
So it's mixed condition and it's minimization. So we'll try to convert all the conditions.
No, which method? See, I have told you something, primal simplex method, dual simplex method. Another is called primal dual simplex method.
Yes, sir.
Some people are vegetarian, some people are non-vegetarian, some people are vegetarian as well as so they can fit to any environment. Yes or no?
Yes,
This
sir.
is an ideal linear programming problem. Yes or no? Because I
Yes.
am taking it in minimization. It is so to this problem you will apply primal dual simplex method together. Primal dual. Sometimes you are using primal criteria, sometimes you are using dual criteria. What is primal criteria? For primal criteria, all the ZJ, you know, at least some of them, sir, ZJ minus CJ are negative. Okay. And our pivoting element has to be positive. For the dual simplex method, all the ZJ minus CJ are positive and the pivoting element has to be negative. I have told you, yes or no?
Yes, sir.
So here both you have to use. Okay. Other thing you know, so I am not going to. Okay. This another problem. Which method will apply? Which method will apply?
So once again, primal dual.
Primal dual together. Okay. So my request is, I will give you the problem. You work yourself. I have given the answer. There may be also some mistakes. No, there may be some mistakes, and that mistakes you can rectify. Okay. But you solve yourself and check my answer. Okay. So at least this work you do. And the last problem you see here. Which one? Which method will apply?
So once again, primal dual.
Primal dual. So for this region I have given, and there are several problems. So after this you complete, then we will discuss about the cutting plane method. If this is not clear, you will commit mistakes, and not only mistakes, you will have doubt. Every movement you will have doubt. Okay, and that doubt your teacher certainly can clear, but I will not have that much time to clear because 160 students. So tell me how many. And I am requesting everybody, if you have a doubt, send a mail in advance, 2 days, 3 days in advance. Okay, so I will read your mail and I will give time. Okay, some specific time you can join and discuss. Okay, over phone, that is fine. You will read the question, I will answer, no problem. Okay, or send this. This is the problem, and send the hard copy. Okay, sir, this is the hard copy. Means PDF file I am unable to get. Okay, this. What is the mistake exactly mentioned? I want to discuss. That's all right. Okay, and your doubt you should discuss, but not with some other. Okay, so together only you send a mail to, what is the mail address? See, mpvisual@gmail.com. Okay, mpvisual@gmail. So this is the mail, means I will say I have a machines where mail is coming directly. I can check. If I am traveling also I can check, but I cannot reply. I will say yes. Okay, but I will reply later on. Okay, that is all right. But this is the, whatever the query you will send there. But when you send a file, send to that one of what I have told earlier. Okay, for the students, I have given a mail ID. What is the mail ID? You are sending all the program, etc. There you send. So because if you are sending to the IIT mail, so I cannot locate. There are also hundreds of mails are coming and you will mix together, and there are some problems, space problem. I am deleting some mails sometimes. Okay, to get the mail. So you send. I think I have written here IAM MP Visual something. I have made something for you. Yes, you send there. Okay. So to that mail you send, and you specify your name, roll number, also mobile number. Okay, because in worst case I can call you and answer. Okay, and if I am calling, I will call in the evening, not in the daytimes. Okay, because that time you will be free. Okay, please remember that. Yes, sir may call me. Okay, that's all. I will certainly call you when I will be free. Okay, I don't have enough work, so night time I am free. I will call you. Okay, if everything permits, we can discuss. See, these are very simple things. Okay, we'll stop here, and these 3 files, these 3 files. So I will send to you. Okay, fine. Whatever I have discussed, and if you want to come to the class, fine. If you are not coming, also fine, because I will not lose. I will not lose my grade. You will lose your grade. Okay. And last semester I have remembered last year, nearly 50% student got excellent. I don't know, because their teamwork is very strong. So, and I was not knowing what they are doing. Somebody told me that they are working together. So when I heard that they are working together, I thought I should also work alone, not together. Okay. So I change this style of question. Again, I will change. Okay. So to know that, yes, see, you are clever, you are intelligent, you should apply your mind. What should the possible question? No problem. But I will not give you the question. So you have to guess. But this question, old question, I will give you. And seeing one question, you can find the pattern of other question. Okay, fine. We'll stop here. The question I'm sending to everybody. Okay, but don't misuse. Don't circulate. You just keep it. This is the question. Okay. Thank you. We'll stop here.
Thank you, sir.
Thank you, sir.